Hello, I am Ethan Seiber.
And I'm Cole Davis, and we're both from the University of Tennessee at Martin, and we're presenting our project, the Kobold engine, which is a 2D game engine. We'll go over our motivations for deciding to do this project real quick. So for me, I've played games since I was young. I've always been into wondering how they work, so I decided I'd start making my own eventually. I've used engines like Unity and GameMaker Studios, even though I like GameMaker Studios a little bit more now. And I've even made a couple of apps for Fitbit device and games on there too that have got a decent amount of downloads.
I have grown up playing video games just like Cole, and I've always had a computer or had an interest in computers, and it was my passion for video games that made me want to create video games later in life. I wanted to do this engine just because it would allow me the opportunity to further develop my skills for video game development.
So a little bit about the project. So like I said, it is a 2D game engine. It allows the user to create basically any kind of 2D game they want. That is all basically done and programmed through the GUI itself. So it's like a game maker engine. It's not too different in theory from other engines like I mentioned earlier that I've used, Unity and GameMaker Studios. It is made entirely in Java, is what it's coded in. We're using certain tools like OpenGL through the lightweight Java game library to create the window, render graphics, take input. To get the GUI, we're using a library called Dear GUI, which creates an immediate user interface, and just a bunch of other sort of small tools like JSON for serialization, but almost all the project is basically done from scratch.
So you might be asking yourself, why choose Java? We wanted this project to be a learning experience for us. We know game engines are typically written in C++ because of its benefits of having data localization, allowing it to be a lot better for performance. But there are fewer tutorials for Java. So what this means is we're going to struggle, or we did struggle a little bit making it, getting it up and running, which meant we had to spend more time trying to learn how everything works and how to fix our problems without having to rely on things like video tutorials.
So I'll quickly go over some of our engine inspirations. First of all is GameMaker Studios, which I've taken the most sort of inspiration from. It has been in development for over a decade by Yo-Yo Studios. It's made with 2D games in mind, and it's really easy to pick up for newcomers and has a really quick workflow so you can get games made really quickly. But even though it is user-friendly and fairly easy to use, it still packs all the features you would want for a modern game. The other engine, which we've taken some aspects from, is Unity, which Unity is one of the most well-known modern game engines of the time, made by Unity Technologies. And Unity allows for creation of 3D games also, which that's its prime purpose, but it can also do 3D games.
We broke the project up into 3 phases, phase 1, phase 2, and phase 3, but we pushed the most important things for a game engine, which also happen to be some of the most difficult things for a game engine, into phase 1. Rendering shapes and textures with OpenGL is a given for a game engine. And then we needed an entity component system, which would be any kind of in-game object like a house or a plant. We also needed a minimal but useful user interface, some of an event listener system so that we can actually get any information from our window and actually use it, and a scene feature. We needed to also be able to upload sprites and show them to the screen. Phase 2, we wanted a functional GUI level scripting language. That's still a work in progress because it's pretty difficult. During phase 2, we want a fully functional UI and some serialization. Serialization being just saving of the scene, saving of the user's progress for a game. And we wanted to be able to pick objects from the scene. So just basically select them and modify them in some way. In phase 3, we want minimum 2D game engine functionality with this is still a work in progress because the game engine isn't finished. We also wanted to get a small game demo finished so that we could show it off.
So this is just a breakdown of our current progress of all the phases. So phase 1 is 100% done. Everything that we went out to get done in phase 1 has been completed. Phase 2, we're almost done, about 85%, because we're only lacking the scripting through the GUI. You can create object logic in the IDE, but the original plan was to get it to where you can write the object logic in the GUI and attach that to an object, which isn't fully functioning yet. And then phase 3, 50%, because the engine itself is fairly functional. You can create a game. And then we have a pretty crude demo that has been made that has essentially all the things in place to be a game. It just doesn't have all the functionality, which just would just take a little bit extra lines of code.
The major tools that we used throughout this were OpenGL and LWJGL. LWJGL is essentially just a wrapper library for OpenGL so that we could use Java to. OpenGL is an open source API for rendering 2D or 3D vector graphics for computers and is written entirely in C. It provides a large set of built-in functions that are usable to manipulate graphics and images. It is extensive, well-known, and still being updated to this day. We wanted to use OpenGL because out of all the other graphics rendering APIs, it seemed like the easiest one to be able to dive into. LWJGL just stands for Lightweight Java Game Library. It is an open source library for Java that allows the use of OpenGL libraries along with other common ones used in video game development. It is notable for being used in the original Minecraft's creation. This is a screenshot of some functionality that we have in place inside our game engine. It's texture rendering. We've got houses and trees and plants, a barn. These were grabbed from a sprite sheet, which is just a large sheet that has all different textures on it, like these trees and plants and houses. We use a sprite sheet because it would allow us, it reduces the amount of files we actually have to read. If we have every texture in one sprite sheet, then we only have to load that one sprite sheet. But if we have them all in different image files, then we have to load each one, and that can really tear down performance.
So moving on to our next tool, DRM GUI, which is really just a library that creates an immediate mode GUI with lots of built-in features that you can use to make all sorts of different GUI windows. So some of those features are things like buttons, you can have pop-ups and like modals. There's custom rendering that you can render things inside of the actual GUI windows, and lots of other various widgets. So here's just a screenshot showing off a bit of the GUI functionality. It is from the original screenshot we showed, but there's a couple new windows open, as you can see. There's the inspector that shows some instance details. There's a scene selector, so you can go from scene to scene that shows different things. You can see the tree on the right. You can right-click objects and add them to the scene, delete them, edit their sprite. And then to the left, there's a scene editor where you can see all the objects in the scene. And there's just a lot of different things you can do with IMGUI, and these are just some of the things that we have done for our project. So we'll go over now some problems and challenges we've had along the way, and I'll let Ethan start us off.
So at the very beginning of the project, we started using Gradle. This would allow us to import our libraries fairly easily, but we ran into some issues because he is using Windows and I am using Ubuntu. We had to figure out how to make both compatible because the libraries, they were originally downloaded or set up to only work with Ubuntu. So we had to make some clauses inside Gradle to where it will also accept Windows as an operating system that it can work with. There are also many memory complications. This comes back to the difference between Java and C++. We can't exactly pass memory blocks around in Java, and that made things a little difficult to actually put together and render to a screen, which is pretty much required if you're going to have a good performing game engine. There was also debugging issues, and this is probably mostly just because we're still new to the whole graphics programming thing. We would have just like textures or shapes not loading, and we just could not figure out how to figure out why they're not working and stuff like that. So it's just little things like that when it comes to debugging. It's just actually getting things rendered to the screen.
So now I'll go over mine. So the first one, it's a lesser of one of the issues I've had, but getting the GUI actually working with everything that it should was a bit of a challenge, because anything that is run inside of like a block of GUI window code is like run automatically every loop in your project. So it's just kind of difficult to account for that when you want to like define a variable and set it to something. You'd have to set it basically inside the GUI class itself, or that scene that you're creating the GUIs for is class itself. So it was a little bit of a challenge sort of understand how that all worked together, but I think I got it working pretty well at the end. Texture loading is another thing that took me way too long to figure out what was going wrong. It was when I was trying to reload deserialized textures that loaded perfectly fine the first time in the program back in once the window was launched. Turns out after hours of messing with like OpenGL function parameters and things like that, I really just wasn't saving the render ID for every texture and not loading in the textures at the initialization of the scene. So bit of an oversight, but it did cause me quite a bit of issues. Understanding the entity component system, that was another big hurdle I had to get over, because I essentially was the one that created the entity component system. And just understanding how everything works, what components do, what components you should have for every object, was a bit also of a hard thing to do, but it is currently working now. And picking, finally. So in order to pick objects from the scene, instead of like getting mouse collisions or something like that and saying if mouse is at position here and you click, and also this object is at position here, click, then that's the object. That would take a lot of checks and it wouldn't be very efficient. So what I had to do, what I got from some tutorials, is you have to make a new shader and run that shader, and that shader basically paints every object that has a specific object ID with a transparent color, which is registered through numbers, an array of floats, and the floats is the object's ID. And so when you click that, you're really just detecting a shader, and it returns the color of the object, which through that shader is the ID, and that's how you get objects. And that took quite a bit of time to implement.
I want to say, because I forgot to mention this, we did find out here recently that one more compatibility issue that we did have came to the picking shader, or just the picking functionality. It works fine for Windows, but it doesn't seem to work on Ubuntu, and we are still working on a fix for that.
There's a couple things that are still work in progress, as you can tell, but I'll now show you what we have going right now for our demo. So this is basically just the editor scene, and as you can see, it's close to the screenshots we showed before. You have the GUI windows, you have the window itself, and at the top left you can see the frames, which usually are around 60, but because I am screen sharing with Zoom right now, it kind of chunks the frames down a little bit. But I can assure you, when I'm not screen sharing, it does go at a solid 60 frames. So I'll show a little bit of capability right now. So right now, if I wanted to add sprite, I could go to this asset browser, click on sprites, and add the sprite. It'll open your file browser, and it works on Windows or Ubuntu, or I would assume Mac devices as well. And you can pick the sprite you want to add. So I'll just add this one, call it cat, because that's what it is, and I'll save it. So now that data for that sprite is inside the engine. Now I can make an object, call it object cat. I can assign this object sprite to be the cat sprite and add it to scene. And here is our cat sprite. And if I click on it, pick it, you can get its values and you can change it. It's Y and it's X. And you can see that it created an instance of it over on the left, which shows all of our instances in the scene currently. So I can go and get some more sprites, save them, create a new object, call it cat2, edit that sprite, give it the cat2 sprite, add that scene, and there we go. We have a new sprite, which automatically detects its width and height and adjusts the scale accordingly. And now we have ID 0, ID 1. And another cool thing we can do is if we go and add another of object cat2, now we have two. They're a bit overlapping, but we can fix that. And if I want to, because the asset browser just contains the data for the object, and the instances are what's currently in the scene, if I want to change the sprite for this specific object, it'll change it for all the instances. So if I can change it to cat2, now it is cat2. It still has the width and the sprite of the original, width and the height of the original sprite, which might be something that needs to be fixed, but I can also change it back. So it changes all the instances at once whenever you're just changing the data for a specific object. You can also delete them. It'll delete all of them. And you can just delete specific instances themselves. So now that I've gone over the functionalities of the game maker part of the engine, I'll show you what you can actually make with that with a little demo that we can go to by clicking the game demo button here and switching to the game scene. So here we just have a very simple little game, like shoot 'em up game, where you're a spaceship, you can shoot lasers, there's enemies coming at you in waves. And as you can tell, currently collision is not set up, nothing happens, but really all you'd have to do for that is just add a couple functions. But this is just a way to show you that making a game is possible with the engine itself. And you might be able to tell the frames are a bit low, around 45 and 30 instead of 60. And like I said earlier, that's because screen sharing. But as soon as I stop screen sharing, it instantly jumps to 60 frames and everything looks really smooth. So the screen sharing through Zoom is what's causing it to be a bit stuttery, but I guess the point across of what you can do with a game. Of course, this is just a very simple example. You can make much more complex things, and of course, you can add logic to it. But this just shows off some of the capabilities we are able to achieve with our game engine that we have made. So that is about everything that we have to show. I hope you enjoy. Again, this is Cole Davis.
And Ethan Seiber.